Okay, now in this next example that we're going to do here, what I want to do is I want to show you a relationship between these answers and something that we're going to use called the discriminant. Okay, so in example 1, the answer we got was 11 plus or minus 13 over 8. Example number 2, our answer was negative 1 plus or minus radical 5. And in example 3, the answer was 1 plus or minus 2i over 3. Okay, so these are the answers that we got for each of these examples. Now watch what I wrote over here. I said we can determine what type of solution we will have by finding the discriminant. And what I mean by the type of solution is the following. We actually have a name for this kind of number right here, meaning a number that can be written as a fraction is called a rational number. Okay, so any number that can be written as a fraction is called a rational number. So basically, I'm just going to say that that's a fraction. Okay, so see how 11 plus 13 over 8, we can get our two answers right there. That's going to be 24 over 8's, get 3, and 3 can be written as a fraction as 3 over 1, right? And then 11 minus 13, negative 2 over 8, that's negative 1/4. So it's any number that can be written as a fraction is called a rational number. Now, if you look at example number 2, negative 1 plus or minus radical 5, this is not a rational number. Okay, it's not possible to represent the square root of 5 as a fraction. You say, well, wait a minute, can't you just put a 1 underneath there? Okay, putting a 1 underneath something doesn't mean that now it's a fraction now, because the square root of 5, if you put that in your calculator, that's a non-repeating decimal. It's a decimal that just keeps going forever. It never repeats. So we call this an irrational number. An irrational number. And an irrational number are numbers that cannot be written as a fraction. Okay, and so basically all the answers that have a square root of 2, square root of 3, not square root of 4, right? Because square root of 4 is actually 2, but like square root of 5, square root of 6, square root of 7, square root of 8, not square root of 9 because that's 3, square root of 11, 12, 13, 14, 15. So basically, if it ever has a radical in the answer, we're going to call that an irrational number because we can't represent radicals as a fraction, okay? And then this guy right here, since it has an I in there, we know it's not even real, right? These are not real numbers. These are what we call complex or non-real answers. They're not real. They're non-real. Okay, so we have 3 different types of answers here. We have rational answers or rational numbers. We have irrational numbers, and we have complex numbers. So basically, the statement I say that actually we can determine what type of solution we will have by finding the discriminants. So I'm going to show you how to find this thing called the discriminant. And by doing the discriminant, it's going to tell us if we're going to have rational solutions, if we're going to have irrational solutions, or if we're going to have complex solutions, meaning non-real. And also, knowing the discriminant will help us determine what method to use when finding the solutions, right? Because we talked about how we can use the factoring method, the square root method, completing a square, or quadratic formula. So now we have 4 methods, and the discriminant helps us to say which one's going to be the best. Okay, so what is this thing called the discriminant? It's right here. What is the discriminant? The discriminant is the value that's underneath the radical. So it's just the b squared minus 4ac. Okay, so specifically, it's the b squared minus 4ac. That's the discriminant, and that's why I kind of just circled that part. Not the square root, not any of the other stuff, but the discriminant comes from the quadratic formula, and this is what the discriminant is. Okay, so if we find the value of the discriminant, it actually tells us what type of solutions we get, and here they are. And you're probably going to want to pause the video and copy down this chart right here. So if the discriminant is a positive number and it's a perfect square, okay, And meaning by that, well, actually, I mean, we're going to do some examples, but if it's a positive number and a perfect square, then you're going to have two rational solutions. And probably I should say it's positive and has a perfect square. So maybe I should probably change that. Maybe we'll just, I can't edit it through here right now, but, and it has a perfect square. Okay. I'm just going to put right here, it has a perfect square, then it's going to have two rational solutions. Remember, rational means that it can be written as a fraction, okay? Now, if the discriminant is positive, but it doesn't have a perfect square, then it's going to be two irrational solutions. Okay, that's going to be the ones with the radicals in there. Now, if the discriminant happens to be 0, oh, by the way, this one right here was just like example 1, okay? And this right here was just like example 2. And I'm referring to the examples that we did in the YouTube videos. We didn't do one when it's 0, but when the discriminant is 0, you're going to only have one rational solution. And when the discriminant is negative, then you're going to have two non-real complex solutions. And that right there is example number 3. Okay? So here I have the rules, and this will always work, and we're going to do some examples here. And my next chart I have are just some examples that already worked out. If you want to copy it all down, you can, but just for you to see here now, okay? I know it's a lot of information, like, whoa, man, you're getting all nerdy on us. I'm trying to give you as much thorough background and information on this so you're understanding why. Okay, so if this is our quadratic, okay, and again, remember, the discriminant is just this part, right? It's just the 1 squared minus 4 times 2 times 3. Well, notice that it's a negative number, right? It's negative. And we learned up here that if the discriminant is negative, we're going to have two non-real complex solutions. Non-real. Okay, so that's why it says that there are no real roots, since no real number can be squared, right? So that means that there are no real roots. It's going to be an I. And just so that you know this, it's not really all that important right now to know, but notice that look how many times that our parabola or our quadratic crosses the x-axis. If this is the x-axis right here, it never even touches it. And that should make sense, right? Because if what we're finding are the solutions, and if it says that we're finding non-real solutions, it should never cross the x-axis. Oh, trickery. And notice that there are 0 real roots, meaning that there's nothing that's real. It's going to be complex, okay? Over here now, what about if we look at this example right here? And again, we're only looking at just what's inside the radical, which is 0. And notice that we only got one answer. And it's called a double root. So graphically what that means, again, we're not graphing yet, but just so you know, graphically that means it's only going to touch the graph one time. And hopefully that makes sense because we are finding the solutions, and the solutions are the x-intercepts. And it's going to hit it one time right there, so there's one solution. And again, let's look at this example right here. If you plug in the A, B, and C into the discriminant, notice that we get two answers. And not just two answers though, but we learn that when it's positive and it does not have a perfect square root. And what I meant by not having a perfect square root, notice that the 17 is not a perfect square. Okay, that's why you're going to get an irrational roots. But yeah, it still crosses it twice right there. Okay. All right, and if that's not enough information, here's one last thing I want to share with you before we actually do our first example here, and that is if the discriminant is a perfect square, including 0, then you would use the factoring method to find the solution. Okay, so that's how you know which one to use. If you use the discriminant, and if it comes out to be a perfect square, okay, if it comes out to have a perfect square number, then you're going to use the factoring method. But if the discriminant is not a perfect square, then you would use either the quadratic formula or completing the square. The quadratic formula and completing the square, they're finding the same thing, so it doesn't matter which one you use. But there's no need to use the quadratic formula or completing the square if it comes out to be a perfect square number there. Okay?